So one of the questions I have been asked is, do I believe the P900 is capable of seeing the ISS when it is over 500 kilometers away? And the answer to that is absolutely yes, of course it can. And we're going to take a look at some of the numbers to determine with a simple experiment just how easily the P900 can in fact see the shape of the ISS at 500 kilometers, and even at a distance of 1,000 kilometers, the silhouette shape is quite discernible. So how big is the ISS? Well, it's 109 meters wide. And how far away is it on a typical transit? We can look at the ISS Transit Finder, and these are some of the upcoming transits in Sydney, Australia over the next few weeks. This one is at 420 kilometers. This one is at 2,000. This next one is at 480 kilometers. This one's at 530, 1,400, 480, 666, 1,045 kilometers, and 785. So we're going to consider the distances of between 500 and 1,000 kilometers, which is quite reasonable for the majority of these transit observations. There's another one, 859. There's another one, 459 kilometers. So we're looking at an object that is 109 meters in size, and it is between 500 and 1,000 kilometers away. So what angular size does that result in? And for that, we can go to an angular size calculator, and we can input the size of the object, and we can input the distance of the object, and it will give us an answer in either degrees, minutes, or seconds. Okay, so what I've done is just tabulate some of those calculations on this next page, where we can identify the approximate angular size. So can a P900 camera see the ISS from Earth? The ISS is 109 meters inside. Looking at distances 500 to 1,000 kilometers will result in an angular size of 45 to 22.5 arc seconds. So for my experiment, I actually drew small images of the ISS on a piece of paper, one of them 2 centimeters in size, and the other one 1 centimeter in size, and I set up those pieces of paper at 100 meters. I was actually a little bit further than that, but let's be conservative. The angular size at that point was 41 to 20.6 arc seconds. So it's certainly in the same range of what we would see with the real ISS 500 to 1,000 kilometers away. So let's take a look at these small images I drew on a piece of paper, and you can see that the small one is in fact less than 1 centimeter in size. The other one is approximately 2 centimeters in size. So these are going to represent the sizes of the ISS at 500 and 1,000 kilometers respectively from a distance of 100 meters in the park. So let's take a look at the results now. So I'm currently at a football field, and I've just taped these 2 images of the ISS. The top one is about 2 centimeters and the bottom one is less than 1 centimeter across. So what I'm going to do now is just walk about 100 meters away and see if we can actually identify those shapes with the P900 at that distance. So here we are at the opposite end of the football field, over 100 meters away. The P900 is set up looking at those printed images representing the ISS. And from this distance, representing scale distances of 500 and 1,000 kilometers respectively, the shape is still clearly identifiable. So we're now located over 100 meters away from those 2 printed images, and the top one represents the apparent size the ISS would appear to be as seen from 500 kilometers away. The lower image represents how it would appear from over 1,000 kilometers away. So as you can see, in both cases, this shape is still quite distinctive. There's absolutely no problem seeing the silhouette of the ISS with the P900 from Earth. I'll zoom out. zoom back in. This experiment demonstrates that you could absolutely see the silhouette of the ISS in front of the Sun or the Moon with a P900. And I'll just pan around so you can see where I am. I'm at the opposite end of a football field.